Configuring and managing storage. Probably one of the most important, if not the most important topic in ESX virtualization is the topic of storage. Because there is no physical, everything is in virtual, which means everything is in code as in software. That means we need to allocate storage and space for all these devices and all of this information to be stored somewhere. We also need to allocate adequate space and architect it properly so that we can have technologies such as vMotion and high availability and distributed resources function properly. All of these need a common ground, and this common ground is storage. This is going to be a really cool module because we're going to get into details on how we architect storage, how much disk space can we do, how not to affect performance. We're going to get into all of these topics that are going to be critical when it comes time for you to build and architect your virtual infrastructure. Because the topic of storage is so important, VMware ESX has a very flexible storage architecture, which includes support for obviously local storage on the actual host. It also includes support for fiber channel SAN storage, iSCSI SAN storage, and network attached SAN storage. We're going to get into details on each and every one of those, fiber channel, iSCSI, and NAS, as we move on with this module. And we're going to talk about the different advantages and disadvantages every solution has and how they can work together, and when you can use NAS in conjunction with fiber channel or iSCSI and fiber channel or all of the above, and what types of technologies you can use on every one of them. So brace yourselves again, this is going to be a really cool module. There's a lot of information here. Now, as I've been saying all along through this video, before you go ahead and buy any kind of hardware for your virtual infrastructure, whether it's storage, networking, or any other component, you want to consult with all the VMware compatibility guides that are available freely on the VMware website. One of the most important compatibility guides that you're going to find is the Storage SAN Compatibility Guide, and we've provided the address on screen. It's a really important guide, so before you go ahead and order any kind of storage devices, any kind of storage hardware, make sure you match it with a compatibility guide. Now, storage is important. But what type of storage is important? Now, shared storage is the one that we're talking about. And why is that? Shared storage is a critical component because it allows technologies such as vMotion, DRS, and HA to function. And what we mean by that is the different hosts that are going to participate in either vMotion, DRS, or HA need to see the same LUNs, the same storage, before they can perform a vMotion, before they can perform distributed resource scheduler, or before they can participate in high availability. So without shared access, if you're moving VMA from ESX host 1 to ESX host 2 and it doesn't see the same storage, then it can't move it. So you see here, shared storage is a critical component because it needs to see where it's moving it from to. And one of the coolest features that was introduced with ESX Server or ESX 3.5 is storage vMotion. I was super excited when I started to find out about vMotion and the fact that you can move a live VM from one host to another without interruption. But I was equally impressed with storage vMotion. The ability to move a live VM's files from one LUN, from one storage to another. It's just fantastic. You're actually moving the whole thing. So now you can move the virtual machine from the host that it's on to a different host, but you can also move its files and folders from one storage location to another without taking that virtual machine down. Now, this is just extremely impressive technology. Now, there are two types of data transfer technologies that are available. There's what's known as block level transfer, which means you're presenting your VMs or you're presenting the guest host in any case with storage that this host or this guest operating system can treat as local storage. This falls under fiber channel SAN and iSCSI SAN because when you're carving up this storage, you're presenting it to the guest operating system or to the guest host, and the guest host is treating it as local storage as if it was on the actual host and not coming through fiber channel or iSCSI. Then you have what's known as file level transfer. Now, with a file level transfer, you're presenting storage that's being managed from a different host. A perfect example of this is if you map a drive letter on your existing host, this drive letter actually resides on another host somewhere else on the network. It is not being presented to this host as local storage, and thereby they're not treating it as local storage. This would be an example for NAS. Now this next slide is a really cool slide. It's showing you the types of data transfers that you can do and the type of cable that you would use, etc., etc. So with Fiber Channel you have HBA or host bus adapters, which are kind of the equivalent of a NIC card but for Fiber Channel. We'll talk about that when we start talking about Fiber Channel. And then we're showing you here the type of cable that you would use to connect to the storage, fiber cable, and then the end result would be a bunch of disk or whatever the storage may be. Now the second one is iSCSI. iSCSI goes over standard TCP/IP, and you're seeing here Ethernet cables. Again, the destination would be a bunch of storage. And then the last one would be NAS and NFS. Again, it's going over the network, and we're showing you the type of cable that you can use. Again, it's Ethernet cable here. Alright, let's move on to VMFS, or Virtual Machine File System. So VMFS was designed with only one thing in mind, and that is the most efficient manner, the most efficient way where virtual machines can live and perform. VMFS was created solely to host virtual machines, their templates, and their ISO files. VMFS is also a very flat file system. It doesn't have all the bells and whistles of other file systems such as NTFS. It doesn't have security on a file level or on a directory level, which can add overhead and could make the file system more cumbersome and slower. VMFS is very, very flat and optimized solely for running virtual machines. Also, unlike NTFS, VMFS allows multiple hosts to have access to the same storage at the same time. Now, if you try to do that with NTFS, you're going to get a whole lot of corruption. You're going to get a lot of blue screens. Don't even try that. But VMFS was customized, was built to allow multiple hosts to access it at the same time. And the way VMFS is capable of doing that is by putting locks on the actual files rather than on the actual volumes. So if ESXA was trying to access a file on a VMFS volume and ESXB was trying to access another file on the same VMFS volume, there would be no conflict because the lock is being implemented at the file level. So whatever file they're accessing at that time, they're locking it rather than locking the entire volume. Now the only time the entire volume is locked is when the VMFS metadata file is being updated. And we'll get into details on that a little later on, because that can seriously affect performance if a lot of metadata file locks are being put in, and that's when you know that you're going to need to have another disk, and that's how you need to learn how to size your disks properly so that not a lot of metadata file locks are in place on the actual volume. Alright, in this next table, which is pretty cool, we're giving you the type of storage here. Let's start with NAS. Now NAS will support SMB and or NFS over standard TCP/IP using a standard NIC. Now the data transfer, as I mentioned to you before, is a file level data transfer, and the performance rating when compared to iSCSI or Fiber Channel is going to be low to medium. The cost also in equivalent is going to be low, so you're sacrificing here. Now with iSCSI, what you're doing is you're doing SCSI over TCP/IP, again via standard NIC or iSCSI HBA. Now the data transfer here would be block level, which I mentioned to you before, which means you're presenting storage to the actual host that's then treating it as local storage. The performance rating would be medium to high, and then the cost as well would be medium. Now the most efficient or the best performing Fiber Channel, or the best performing storage technology today would be Fiber Channel, which would be SCSI over Fiber Channel using Fiber Channel HBA. Again, you're doing block level, the performance rating is high, and the cost is obviously high. Alright, now let's take a look at some of the storage feature summary here. Now with Fiber Channel, as you're going to notice, you're going to be able to do everything that you can do in a virtual infrastructure. You're going to be able to do vMotion, DRS or Distributed Resource Scheduler, HA or High Availability. You're going to have VMFS. You're going to have RDM or raw disk mapping. You're going to have VCP or VMware Consolidated Backup. You're going to be able to do Microsoft clustering services. Now with iSCSI, you're going to be able to do all of the above, everything you can do with Fibre Channel, with the exception of Microsoft clustering. Now, with NAS and NFS, your features, as you can see, shrink. Now you can only do vMotion, DRS, HA, and VCB. With local, if you're using local storage, you can obviously have VMFS, you can do raw disk mapping, and you can do VCB. Now, why can't you do vMotion or DRS or HA with local storage? Anybody? Because shared storage is not available with local disk. ESX hosts need to have access to the same shared storage before they can do these functions. And if local storage is on ESXA, ESXB can access local storage on ESXA, thereby it won't be able to take advantage of these technologies. Alright, let's move on to Fibre Channel storage.